They decrease the risk of catastrophic failure for bridges, dams, aircraft, and much more. With recent structure collapses making headlines, we're putting the critical work of SwRI's structural engineering team in the spotlight. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast presented by Southwest Research Institute. Hello and welcome to Technology Today. I'm Lisa Pena. Our guest today is SwRI engineer and director Tim Fye. His team of structural engineering specialists have a critical job. They assess infrastructure to identify problem areas and shore up weak spots. And all of us are safer because of their detailed inspections. Thank you for joining us, Tim.
Thank you, Lisa, and hello.
So we want to get your perspective on the recent condo collapse in Florida and other recent structure collapses in a moment. But first, let's talk about the important work you do. Here at SwRI, we have an entire department, your department, making sure structures and their components hold up and withstand all types of forces. We test everything from underwater vessels to aircraft. How do you describe what you do in the structural engineering department?
Our department services a very broad client base, both government and commercial. We follow very detailed engineering practice to help clients at various stages of their programs, all the way from design to analysis, manufacture, testing, and inspections, so that we are completing a cradle to grave type solution. And we can come in at various stages of a client's program, depending on their needs.
What's the goal that you have in mind for each client, and why do they bring you on board for their projects?
They bring us on board because we have seen so many projects through the years. Our expertise has grown, our experience, and they are in some ways looking for an independent evaluation or additional support in a given technical area. They bring us on board such that we can help them, in so many words, solve their problem, but I think come up with a structure that is safe and will perform its intended function as they are wanting to do.
And I think that's the bottom line in all the work you do: safety and having structures, as you mentioned, performing as they should. Tell us about the range of structures your team works on.
Okay, we have worked in areas from underwater structures, both manned and unmanned vehicles, submarines for both government and commercial. For recreation, we have people now building submarines for their own recreational use. We do highway barrier systems and other security barriers, looking at their performance. We do aircraft structure. We have helped with new design, but also most of our work has been in keeping older aircraft capable of flying and completing their missions. We test a variety of underwater equipment. We've also have been involved in safety equipment for nuclear power plants, telecommunications equipment. We've built inspection equipment such that we can do a better job of inspecting structures and infrastructure once it's in place or after it's been aged for many years.
And again, your goal is to make sure that these structures can hold up under a range of circumstances. So will you walk us through what an assessment looks like? Let's say for an aircraft. I know that's a structure your team works on often. Right. So, walk us through that. What would that look like?
It really all begins with understanding the usage of that aircraft in this case, or other structures. what type of loading or environment it will see, whether it's a natural type environment, such as wind loading, earthquake, wave motion, corrosion, things like that. Choosing the right materials and making sure that the proper material is chosen for that application and having the right properties to meet those requirements. Doing some testing in some cases to look at other properties of that material to see what type of physical property it will have when something begins to fail or crack. So crack propagation, a fracture mechanics type approach. Also perform all the analysis to support our design. And in many cases, we will do the testing, build up the hardware and do the testing to validate what we've done in our analysis or qualify that system for its use by simulating those environments and loading that structure is intended to be used for.
So it sounds very thorough. You're looking at the structure as a whole, you're looking at each component, you're making sure everything is working as it should. And you are actively working to prevent failure. So, it seems obvious, but what could be the consequences of a structural failure? What types of incidents does your team actively work to prevent?
Yes, as you know, and most know, we obviously look at the risk involved in our structure, which includes not only the probability of something occurring to it, but then the consequences. And in the case of many of our structures, it could be loss of property under an event, which would be a financial impact to some organizations or some individuals or entity. Loss of property. We also have, worst case, loss of life. And in many cases, it could be a very catastrophic event where you lose many lives. And so if you have a very high consequence of things happening, and particularly when you have loss of life, we spend quite a bit more time and effort in the design and in the testing to make sure and look at our safety margins that we use in our design, and likely will increase those safety factors when we have very high consequence in a given situation. So that's really what could happen under some of these failures. You could get a big environmental impact. You get a whole nuclear power plant that may have an issue, as we've seen in the past. Could have bridge collapse on the traffic, killing people. We have aircraft, maybe single passenger or pilot and passenger, or commercial aircraft. You need to look at the consequence that we're dealing with. But those things are all possible when we're talking about the structures that we've looked at through the years. We definitely don't want a diving team going down in a capsule or a vessel and then having that collapse under the high pressures of the underwater condition.
And with each structure, you're assessing something a little different. So what are some of the tools you use to assess a structure and its components?
Many of the tools are classical engineering type tools that we are given and learn in our education and through practice. Some classical analyses, also some higher level analysis tools. We also have at our disposal the NASGRO software. NASGRO has been with us for quite some time. It's on its 20-year anniversary. And so that's there to help us look at fracture mechanics and the fatigue side of it. That's also a very important aspect of structures, is how they will be used, how many cycles they will be loaded. And we look at fatigue, in other words, trying to predict what type of end of life they will have, or at least design so that they will meet the intended number of cycles, like opening a car door, for instance. That's a very simplified example. But an aircraft, how many flights will it take? How will they use that? So the tools that we use to do that are a combination of analysis tools, both classical and more sophisticated. We have the fracture mechanics approach that we use. And then we also have a laboratory at Southwest Research Institute, many laboratories where we do a variety of testing. So that's available to validate how we're designing and modeling these structures, and also do qualification tests and verification uh, for the hardware in a intended environment.
Are you using robotics in your work?
Yes, we do. We, in many cases, want to know the condition of a structure. If we can identify something that's going on, whether it's a flaw that was there during manufacture of that structure, or if there's something that's occurred through corrosion or a fastener rubbing with the material, we want to be able to inspect. And a lot of times you can't just be there as a person because of the environment around you. So we have built robotic systems with our sensor techniques and our sensors that we build, and the analysis systems that go with that. But we integrate that with robotic systems. Most recently, we've worked with a robotic system that will inspect a tank wall for corrosion. And that tank is a fluid tank that's land-based. And basically, if that were to corrode through, we would have an environmental concern of the contents getting into the environment. And so we can't get there with people, and it may have uh, a hazardous environment, in this case, radiation that may be occurring. And so we put that on a robotic system that will then track, like a tracked vehicle, to crawl into this space and do inspection of that structure.
So I did want to talk about the NASGRO software a little bit more. You mentioned that it was developed by SwRI and NASA. So how does the software work?
The software is a it's a very most widely used fracture mechanics and fatigue software. And so it has a database of properties of materials over many years. Um, we have the ownership of that software. It was originally developed by NASA, and roughly 20 years ago, the SwRI gained the ownership of that and continues to upgrade and modify that software. We sell licenses for users to operate that software. So it's not only us doing it, but we allow other users to use that software. But it does help us predict, if we know the properties of the material and have the data to support that, or we develop the data. In a lot of cases, the software does have the database, as I mentioned. We can then look at growth of a fracture or a crack in a structure, if that occurs, and how fast it will then propagate or grow. So we can predict how long a structure will last before a failure or potential failure, or we can predict when we should inspect a structure to look for these types of things that are going on that we've modeled, so that we can catch them before, hopefully before a catastrophic event. So it gives us high confidence using this tool that we can set a inspection cycle or come up with a life or fatigue life of a structure, such that we can help prevent those catastrophic events that we talked about.
An SwRI team conducts trainings on NASGRO. Right now, due to the pandemic, we are conducting those virtually. Can you tell us a little bit about the trainings? What do clients learn when they attend?
Yes, SwRI provides short course training, I believe 2 times a year, that's open to many participants. And we also provide on-site or client-specific short course training internationally. So the attendees get hands-on experience using the software. They're given the computer, in some cases, operating the software, working with our experts, our trainers, and applying the tool to real cases or examples that they learn how to then use the software and are able to go back to their work environment and do it themselves.
Okay, and those trainings take place over 5 days. And I did see the dates for our next virtual course are September 21st, 22nd, 23rd, and
That is
September
correct.
28th and 29th. So the next course will take place over those 5 days. Our listeners can learn more at swri.org/NASGRO training, and we'll have that link available on our episode 34 webpage. So moving on to our next question, just curious, what have been some of your standout or most memorable projects over the years?
What comes to mind are some of the larger hardware programs that I've been involved with. We performed the full-scale static and fatigue test of one of the very light jets, one of the early very light jets several years ago. That includes building up the test hardware to support the testing, but it reproduced the flight for the fatigue portion of that very light jet from taxi to takeoff to cruising altitudes to landing. And so our test apparatus, provided those loads, and including internal cabin pressurization. So it was a very integrated test program, but not only testing, but it was all the data analysis, the data acquisition, everything that went along to help that client certify their aircraft through the FAA under their quality systems. Another one that comes to mind most recently is being involved in the manned submersible named Alvin that most people have heard about. This is a deep diving manned submersible, and we designed and built sphere that goes on the Alvin. And so that was a very integrated and lengthy program that was very interesting, and the impact obviously is great on the use of that. I've also been involved and with a program that comes to mind for testing a large scale heat shield for a Titan rocket, the base of the Titan rocket years ago. And so that involved a lot of designing and building of the hardware in support of that validation or qualification of that heat shield that flies a very important mission. But every project is always somewhat different, whether it's large or small. And I think they all are memorable. I remember just about every one I've done. And at the time, it's the most important project to the client, and it is very important to us. And sometimes just even little segments of a client's project can have a very important function to meet that whole intent of that client's project that they've got going on. But those are some of them that come to mind, Lisa.
So, at SwRI, we say we do everything from deep sea to deep space and everything in between. And it sounds like your team has definitely handled the entire range of that. So, from your underwater experience to the rocket going to space. So, really neat. You guys do a little bit of everything. So, what type of projects is your team currently working on?
Well, currently, we're doing sustainment of several aircraft for the Air Force. There's a T-38 and an A-10 that have been in service for 50 years. We're still using that. So we need to keep that safe and help through our aircraft structural integrity program to make sure those aircraft continue to fly safely and help the Air Force, understand the state of that, the risk, where we're at with that platform, and be able to inspect it in the critical areas such that we know it will continue to fly safely or as best we can. And other aircraft systems that we're currently working with, but those are the two major ones. We're also designing and building what we refer to as blast chambers. So these are large structures that will contain blast loads. So someone will put something in there and explode it. And the intent of this enclosure, this big system, is to keep the blast contained so that the environment around doesn't have to listen to it, doesn't have to feel the blast waves, and doesn't have the byproduct of that blast going into the environment. And so we're building those right now, designing and building those. Those are very large structures. And we're also testing, as I mentioned earlier, highway barrier systems. So we're crashing vehicles into highway barrier systems. We're looking at security barriers. We are inspecting and helping aging infrastructure in the area of guy wires for antenna towers and other towers. And we continue to do work in support of our nuclear power plants, both domestically and internationally, by either testing hardware or building inspection systems. One of our big programs is supporting the Japanese nuclear market by selling inspection equipment, designing and providing that technical assistance during in-plant inspections. So these are just to name a few. We have many projects going on at any given time. And as I mentioned, they're all very interesting to me and very important to me and also the clients.
Yeah, you are busy. So you talk about it very calmly, but in the course of that explanation, you're talking about blowing things up, crashing things. And I think it's important for our listeners to know, that's just a day at SWRI, right?
Right. Well, you put it all together at SwRI, and it's not just my department. In some cases, we're supporting internal clients, our projects that are done throughout Southwest Research Institute. But we concentrate our work mainly on those structures that help withstand the loads. In other words, hold something together or provide some method of transport, whether it's continuing safe transport in pipelines or bridges, as we mentioned earlier, building structures. So, we have everything from aerospace to power and energy type systems that we help build. We also build pressure facilities and chambers that hold internal pressure so that we can help people test underwater equipment. So we design and build it such that it can provide very high loads to that equipment when we're under test.
Yeah, we do the exploding, we do the crashing, we put all sorts of forces on these things so that when they are being used by the public, they perform as they should. So,
right. And one other thing I'd like to mention also is the whole aspect of keeping the aging structure or the aging infrastructure moving and safe. Some of these systems I mentioned are very old. So we've developed a process, and it's an industry practice of how do you identify and extend life of a structure. We indicated the Air Force aircraft we talked about. But we have a program called Fitness for Service, which we've included everything from valves that are on pipelines or in process plants, nuclear power plant components, things that have reached an end of life based on their original design, but are still in service and could be operated safely if we had the confidence to do that. And so we help through our process provide that confidence to the users such that they can continue to use that in a safe manner.
Okay, another area that you are experts at is taking that older infrastructure and making sure that it's improved over time and continues to be useful.
Correct.
So I want to go now to those collapses making headlines recently. Um, so there have been some major structural failures in the news. On June 24th, a 12-story condo complex in the Miami suburb of Surfside, Florida collapsed. Dozens died at the time of this recording. The exact cause is under investigation, but a 2018 report revealed the building showed signs of major structural damage. Just a day before that, on June 23rd, a pedestrian bridge collapsed in DC after it was hit by a truck. 5 people were injured there. The bridge was deemed to be in poor condition during a routine inspection prior to that accident, and it did not meet standards for height clearance. So, when you see headlines like these, when you hear stories like these, what goes through your mind as an expert who works to prevent these types of catastrophes?
Well, first, I want to be clear that I'm not directly involved or been involved in projects uh, with these projects, with these catastrophic events that we've mentioned. But much like the rest of the public, when I hear these things, first it's a shock. Obviously, why did you know in this occurrence? It's somewhat questioning in my mind. Could that have been prevented? You know, many times I feel very disappointed. Being an engineer because we try to do everything such that it will be used properly and that it will be safely used for many years. And we're trying to prevent those consequences that we talked about earlier. So, as an engineer, when I see things like a bridge collapse, a building collapse, a space shuttle go down, it's very disheartening, much like I guess everybody feels. But I think it hits harder when you're an engineer involved in a lot of these systems through the years. Um, so, it's disappointments also because we provide a process to help our clients to try to prevent that. And we know we do that through finding problems in aging equipment and then either helping the client decide do we take this out of service? Do we repair it? That's through inspection. In some cases, you don't even need much inspection for some of the obvious condition of that I've read about anyway on some of these things we've talked about. But acting on that in a timely fashion such that you don't get to that catastrophic event. So it appears to me, reading some of the same things that you've been reading, Lisa, that, these things were not a surprise. That, in one cases, people on the waterway had seen some problems looking up in their kayak at something. Another case, we have building inspection reports. We inspect structures like aircraft, and then we see what we find. If it's severe enough, we recommend stopping that flight of that aircraft at least, and maybe even a whole fleet. So we have a process then to say, okay, we've got a problem. What are we going to do about it? Can we continue to use it safely? And when would be the next inspection? Such that we try to do that inspection well ahead of any predicted next occurrence that you might have. So yes, it's unfortunate, I think, that when we have methods and people see things that I think in some ways we aren't reacting quick enough, or in some cases we don't have a formal enough process, much like we do as this fitness for service I mentioned, where we would then help people move forward in a more safe fashion where we will hopefully prevent a catastrophic event.
So when a problem is identified, immediate action is would be ideal rather than letting the problem fester and waiting for time to pass and for it to get worse. you kind
Yeah,
of see you see opportunity for immediate action and remedy the situation
yeah,
before something like this happens. Yeah.
yes. And I think if we had, in some cases, when you're dealing with something that's owned by the military, you can have quite a few procedures in place. In some cases, when it's unclear the process, then things can fester, as you mentioned, and you might potentially have these types of problems. But it is frustrating to see that it wasn't unknown that they had problems in these cases we were looking at. But I think no one really expected it to have a catastrophic event, or they would have stopped it.
So I see you and your colleagues, your team, as kind of unsung heroes preventing disasters. And, the public, we just expect safety and integrity in the structures all around us, but you're the ones making it happen. So here's a public platform to give a shout out to your field. What would you like our listeners to remember about your work and the structural engineering field?
I think most importantly that, we have an engineering process. There is an engineering process to produce functional and safe structures, in this case, and equipment, and help decrease the probability of a catastrophic event occurring and perform their intended functions. And that we understand that in our department, and it's SwRI. We have that process and we can help. So I think that's the message I'd like to leave with.
All right. And as you know, Tim, at SwRI, we are committed to advancing science and applying technology to benefit humanity. That is our mission. And your team's important work, keeping people safe by ensuring structural integrity, brings that mission to life. So thank you for the work you do. And thank you for joining us and giving us a peek into what you do every day.
You're very welcome, Lisa, and I was honored to be asked to be on the podcast, and I thank you for hosting me.
And thank you to our listeners for learning along with us today. You can hear all of our Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.